Okay, so let's have a look at when two vectors are equivalent. Basically, two vectors A and B are equivalent only if their components are all equal. Okay, so each of the I, J and K components need to be equal if A is equal to B. So let's just have a look at a quick example. If A was equal to 3I minus xj plus k, and B was equal to yi minus 3j plus k, then if these two vectors are to be equal, then all the components need to be equal. In other words, this is equal to this, and this will be equal to this. And k is equal to k, so that's okay. There's no need there. So therefore, it's very simple. If 3i is equal to yi, then y is equal to 3. And also, if negative xj is equal to negative 3j, then x is also equal to 3. Shame on me for picking such boring numbers, but there our values there. So that's very, very simple. Two vectors are equal, then all of their components are equal as well. Very simple. Let's have a look at magnitude. What's the magnitude of a vector? Well, it's fairly simple. Remember, the magnitude is its length, and so in our rectangular components form, which is pretty much how we're going to work from now on, if A is equal to, let's just go straight into it, xi plus yj. So if it's a two-dimensional thing, and you think about it, what this means is it goes across x and up y. So there's our vector there, there's A. It goes across x and up y. Think about it, what's the magnitude of A? So the magnitude of A will be equal to Pythagoras, the square root of x squared plus y squared. Simple as that. That's how you figure out the magnitude of a vector. Example of that was if A is equal to 2i minus 3j. Yes, Matilda. Okay, go to bed, please. I'll come in a second. That was Matilda bothering me as per usual. We've got our vector there, A is equal to that. What's the magnitude of that? Well, the magnitude of A will be equal to the square root of 2 squared plus negative 3 squared, which is equal to the square root 4 plus 9 equals root 13. So that's the magnitude of A. Let's have a look at a three-dimensional example. So B is equal to 2i plus 3j plus k. Again, the format for the magnitude of any vector B, or any vector really, will be the square root of x squared plus y squared plus z squared. That's if B is equal to xi plus yj plus zk. Okay, so there's the magnitude of any vector. Magnitude is equal to that. Okay, so very, very simple. To find the magnitude of B will be just equal to 2 squared, 4, plus 3 squared, 9, plus 1 squared, 1, 4 plus 9 times root 14. So that's the magnitude of that vector. Nice and easy. Just lastly, just the angles between axes. So just the last little piece. So say we have some vector going out in that direction. It's often handy to know what the angle is there, so let's just call it alpha in there between the x-axis and the vector, and that's the usual one, to be honest, the angle between there. Often we also would like to know there what's the angle between the vector and the y-axis, and also we often like to know what's the angle there, what's gamma, like that. What's the angle between the vector and the z-axis? And basically, there's a lot of simple ways to do this. I can never remember these formulas, but they're very easy to show. Then in fact, the cos alpha is equal to, let's define what our vector is. Let's call this vector A. If A is equal to xi plus yj plus zk. Oops, what happened there? Okay. If that's our vector, then cos alpha, cos alpha will be equal to x over the magnitude of A. That'll be the angle alpha there. So that's, and you can see cos, it makes sense. Cos of the alpha angle is equal to this x, whatever the x value of that is, and also over that. So it's just simple trigonometry. Similarly, cos beta is equal to the y value. What's the y value? Y over the magnitude of A, and also cos of gamma is equal to the z value over the magnitude of A. It's very simple, it makes sense, but that is worth remembering when you're trying to find the angles between vectors and axes. You can also use something else with dot products, but we haven't got to that yet, and I'll show you. But that's how I usually use dot products when asked to find angles between things. That's basically it for this video.